G'day guys, it's Calvin from the Cartoon Company down under in New Zealand. I thought I would do a really simple video on thermostats. And then my brain started ticking over and I realized that that might not actually be adequate to really explain the thermostat operation and the reasons behind it. And then I started thinking that maybe we should discuss all of the cooling systems within an engine. I was thinking it'd be a really good opportunity to talk about cooling while I have this engine on the floor that's all running with a cooling system plumbed up. And the basic idea came about because I managed to find some TRD sports performance thermostats. And it's really a topic that is very basic, but there's still a lot of misconceptions and I'm going to say probably myths around how to do it, what to do it, and what you can and can't do with a cooling system and why. If I manage to get half of what's in my brain on this out in a legible form, I'll be pretty happy. But I thought I'd start by doing a really quick brief. Okay. You have an engine. It needs to stay within the correct operating range so that it gives you the best life of engine and the best performance. Too cold is bad, too hot is bad, in the middle is pretty good. Fortunately, Toyota's done all the hard work, or Lexus, they've done all that hard work, and they've built a system that works in standard cars, and it works well with a standard thermostat. So if you've got a standard car with a standard engine, then the standard thermostat's probably going to be your best option. That's really simple to understand. If, however, you've got a conversion, modified engine, engine swap, and you wish to tune or adjust your cooling system to suit the way it's set up, then this may be an option. And whilst I don't like to recommend band-aids, I also understand that there are situations such as high ace vans where we put a big engine into a small hole with not ideal airflow. So we have to come up with good solutions to overcome it. And they actually work really, really well. And I don't really consider that a band-aid. I just consider that tuning the cooling system to suit the application. Also in four-wheel drives and trials trucks, where we want them up to temperature, and then they get the nuts wrung off them for a very short period of time. Race cars, then we would expect a performance thermostat may be a good option. And thanks to some good buggers in the UK, I'm also going to offer a Mitsubishi option, which works. And they look good, 76 degree, as another option. And thanks so much, guys, for sharing that, because that's bloody good of you. I want to encourage intelligent conversations on these topics. And I really appreciate guys that do engage in intelligent conversations on these topics. Okay, temperature ranges. We have an engine. How hot or what temperature and what cooling is going into this engine? Most guys will say, of course, they'll come up with the radiator. That's the cooling. And that's a really good start, but there's more cooling to an engine than just the radiator, which is the cooling system. We have airflow going into here, going into that engine, creating some cooling effect. So airflow into the engine is having a cooling effect. Just something to think about. Now the next thing we're putting in with that air is some fuel. So that has a cooling effect on an engine. And those boat things that I work on, those ones we feed methanol in. And it makes a massive difference to the cooling of that engine. On this topic, we're not too worried about the air and the fuel, but it's just important to remember. Of course, we've got the water system, or the radiator system. This one is for a boat, so it's got a heat exchanger, and will allow me to do some very even testing on it, which is really cool. And of course, there's not just air going into the engine. The air is acting on the radiator. The air is acting on the engine itself, on the sump. So those have an effect. Airflow, air is where we're getting rid of that heat. We're transferring it from the coolant into the air. In this case, the coolant into river water, which is then wasted. So there's something else that has a cooling effect on the engine. Because we can't get coolant, antifreeze, I'm not sure what to call it. I might just call that water, to that. So the bit that's having a cooling effect on the bottom of there and on there is the brown slippery stuff. And the brown slippery stuff works in conjunction with the cooling system, the watered cooling system, to keep the engine cool. So keep that in mind. Now, what is that ideal temperature for your engine? I've got 3 thermostats there. I've got a 71 TRD Sports Performance thermostat. I've got a 76 Mitsubishi thermostat. And I've got an 82 genuine Toyota thermostat. The VVTi also has a very similar system, so this information will cross over. Okay, so an engine has 3 stages of cooling or of heating. It has not enough hot, it has hot, and it has too much hot. And we'd like to keep it in the middle. Now, not enough hot is bad. Too much hot is bad. But hot is ideal, in the middle. We could itemize that further, of course, and go hot, but at the top of the hot and at the bottom of the hot, and that's too tricky for today. Let's just call it up to temperature or ideal running temperature. So what we're aiming for is an ideal running temperature. As I said earlier, Toyota's done that for us in a standard car. So if you're running a standard car, run the standard thermostat. It will open at 82 degrees. It will continue to open until it's fully open with 10 millimeters of lift at 95 degrees. And they work well. Do not remove the thermostat because there is a bypass circuit. With the brown slippery stuff, it is going to make a difference to the quality and the life of your engine, and to some extent the way it removes heat from the internal components of the engine by the quality of your oil. Will this protect your engine as good as that? There are some arguments people will put forward with regard to changing temperature ranges of your thermostat. They will say things like, it won't remove the contaminants from your engine. Water. I just tipped it on my floor, not deliberately, but it will work for what I'm trying to show. Petrol. Unburnt petrol. There could be some of that in your oil. Both of which can be removed with heat. We'll come back to that though. But other contaminants, physical dirt. If you've got dirt, external contaminants in your engine, you've got other problems. I actually had a customer who had sand in his engine, possibly due to a very jealous ex. No amount of temperature is going to remove that from your engine. It's stuffed, you've got other problems. Another contaminant is carbon. If you've got carbon build-up, again, you've got other issues. You possibly need to look into them before worrying about temperature of your engine. So temperature can have effect because a more efficient engine will make things burn better. But not really something that temperature is really going to help with getting rid of. Changing the oil and doing engine repairs is going to fix carbon more than temperature. Other contaminants? Metal. If you've got metal in your engine, it's stuffed. Throw it away. No amount of temperature is going to solve those. So back to the two that temperature does affect. Water. And I'm not talking about water from a blown head gasket. I'm talking about normal water from the atmosphere. What temperature does water evaporate at? Unburnt fuel or hydrocarbons, petrol. What temperature does that evaporate at? Now I actually took some time before starting this and I tipped some petrol on the floor. To really make a decision, we probably should know what the temperature is here today. So I take my heat gun and I test the engine behind me. 21 degrees in here at the moment. And that will come into play soon. We would call that not enough hot in our scale of engines. Yet I'll show you where I tipped the petrol. It's that stain there. Coming up on my dash, it's saying around about 20 degrees in here. So gives a bit of an idea of the temperatures we're working at. Interesting enough, my concrete's actually retaining a bit more heat. It's telling me 23, 24 degrees on the concrete. But the latent heat of my concrete has evaporated that petrol. It's gone. I actually, in the last couple of days, it's been about 35 degrees in the afternoon. The petrol in my bucket of noise, in my fuel pump system, has disappeared by about 2/3. So it's about 1.5 litres, a litre of evaporation at 35 degrees. Water. Now guys will say it boils at 100, but what does it actually evaporate at? Now here's my water puddle that I prepared earlier. It was right out to my finger. And again, this much here has evaporated off. Lots of concrete over here. The concrete over in this part of the workshop, 22.8 degrees. So what is the ideal temperature? Well, most manufacturers these days tend to be 80 to 90 degrees. I was in a late model BMW the other day. That was at 105. And then guys go on that, hey, we're over boiling points. We probably should understand just a little bit about pressure. The cooling system has got one of those on it. A radiator cap. An increase in pressure will increase the boiling point of whatever fluid you're running in there. The chemicals we add to our water in our cooling system are going to affect the boiling point. This stuff, whether it be green stuff or pink stuff, that one's probably more purple. Of course, there's other advantages to antifreeze, such as the anti-corrosive qualities of it. So they're really, really important. So you should always run an antifreeze of some kind, and I don't recommend mixing between pinks and greens and reds and purples and blues, because you get an ugly colour of something else. And sometimes it turns to jelly. And how does water temperature relate to oil temperature? You'll hear guys say that oil temperature sits 10 to 15 degrees less than the water temp. You'll hear guys say that they run the same. And you'll hear guys say it runs 10 to 15 degrees hotter than the water temp. And I probably should say I'm working in Celsius. Crossing it over to US measurements is just too tricky for me today. 80 degrees Celsius is about, well, 82 degrees is 180 degrees Fahrenheit. I've got that one sorted. Now, who's correct on where oil temperature sits? Well, all of them. Depending on the setup, you can have different oil temps. And I think what I'm going to do, in a second video, I'm going to fire this engine up and I'll do temperature measurements around the block. And we'll have a look at the system a bit more. We'll do the practical rather than the theory. On the LS400s, they've got a cooler unit. Thinking about that, it would probably be better to be called an oil temperature stabilization unit. It helps them keep the oil temperature more even. On the note about oil coolers too, I've seen plenty of guys put aftermarket oil coolers onto their cars and wreck engines. Too cold, not enough hot. So if you're doing that, thermostatically controlled oil cooler is recommended. Okay, so we're talking about hot here, trying to get things to hot. Guys go do the opposite, cool stuff off too much, kill engines. That's the not enough hot. Oh, they're calling this cold. Ideally, it would sit in the middle like that, and that's too much hot. That's bad. This, of course, in reality, what happens is you're driving, it sits there, and then you're parked, it actually goes up to there like that, and the fan comes on and it comes down there like that. That might sit with the fan and it's up. You're driving again, it's down there. Toyota thought that would freak people out, so they made it so that's like cold, and then this is like 30 degrees, 35 degrees, and then it goes whoop, and it sits there, and it just stays there, and you don't get any movement, and it comes up 50, 60, 70, 80, 90, 100, 105.2, and at 105.3 it goes like that. It's pretty much how a Toyota temp gauge works on a Hilux. Some manufacturers these days, to solve that problem, just put a little blue light on it with a temperature symbol when it's cold and a little red light when it's hot, and they don't have any other gauges. No temp gauge. I'm not sure that's a good idea, but who am I to question on that? Nothing I can do about it. Now, of course, the oil, the brown slippery stuff, is designed to work at a specific temperature. Everything in the engine is designed to work at specific temperatures. At what temperature does this stuff stop working? A lot higher than this stuff. Now, of course, oils have an operating range. Better oils will go hotter. And when we talk about oil temp, a lot of oils, it's game over at 120 degrees. And you might say, hey, well, I've got a temp gauge, it's never measured more than that on my oil temp. But remember, if you're running turbocharged or pushing them really hard, there are parts of that engine that are hotter than that, especially in your turbocharged. So we don't want to get into the other contaminant of baked carboned up oil, turning back to what it came out of the ground as, because we don't want coal in our engine. No amount of heat, drop, positive, negative, it's bad. It's always bad. I used to work at a turbo shop. I've seen the effects of cheap oil going through turbos. The same is true for the rest of the engine. There are hot places in there, so good oil helps keep that engine cool and, of course, lubricated. I was chatting to a man just the other day. Modified cooling systems, race cars, average oil temp logged 105 degrees. But he's running an oil that's good for about 160 degrees. And when you start getting to that level of sport, knowing the specs of the products they're using is really important. I'm going to go through in my practical session and measure some temps, but generally oils are designed to work around at 80-90 degrees. They'll still protect and remove contaminants perfectly fine at 70. And like my example over here, the longer I leave it, the more it will evaporate, even at lower temperatures. So running an engine for longer trips over shorter trips is going to have an effect. And we want that engine to heat up as fast as we can, because every time we start it from not enough hot, it's bad. So the faster we get it up to temperature, the better. Toyota does it by running a bypass thermostat. They have that valve sitting in here, water comes out of the hot side of the engine down into the supply back to the water pump. The thermostat is located on the inlet to the cooling system. This is the outlet, this is the hot. This is effectively the cold. Hot, through there, back into the return to the engine. So we want this engine to heat up fast. We want it to stay at temperature consistently within the range. And of course at the other end you've got fans keeping it cool. Airflow through the radiator. So if you've got a standard engine, put the standard thermostat in it. That's going to be the best way, the best thing you can do. If you've got a less than ideal cooling system, or you want to manage and drop the temperature a little bit, really common in surfs, big engine, four-wheel driving, big tyres, then some other options. Race cars, but watch that you still get enough temp in your oil. And often I see in race situations, the oil is hotter than the water temp. So we can tune that by bringing it down with different thermostats. There's a heap of cars over here, and I'll show some of them soon, with totally modified cooling systems. Front water bridge is gone, thermostat's gone, thermostat housing's gone, and it's controlled in other ways. But we'll look at that another day. That's the part number of a 76-degree Mitsubishi thermostat that will fit a 1UZ. So there's the 76-degree Mitsubishi one fitted. We can see in here, and we can't quite see, but there is still flow for the bypass. Still going to close the bypass off, so that's a good option. The TRD thermostat opens 71 degrees, but it won't be fully open until into the 80s. And we normally expect a 10 to 15 degree drop in temperature for this thermostat. This is actually already allocated to a job, and generally the guys that are buying these know exactly what they're for. Trials truck, competition truck, sits idling a lot, wants to see temperature, but then it's sitting at 5,000-6,000 RPM for 2 or 3 minutes, just hard out, even up into the rev limiter. So the performance thermostat is perfect. This vehicle, pushed hard, lots of time, 4,000 to 5,000 RPM. It's getting an aftermarket ECU as well. It's got a good radiator, it's got a good cooling system. The thermostat is keeping the temperature up there. And he wants to drop temperatures 10 to 15 degrees. It's the perfect option. So, performance-wise, for a performance engine, that's a good choice. For a standard engine, the standard one's a good choice. This is just a tuning tool. It's an adjustment tool that we can set up our systems the way we want. The manufacturers have spent a lot of time developing these engines and making them work in standard cars, and then we go adjusting it. And if we don't adjust it too far from standard, stuff like this, that TRD gave us the tools to adjust it to suit our needs. So real quick summary. Good oil, good cooling system, understand the cooling system, run your engine up to temperature, it will last and it will go well and give you a good service life. I hope that helps you a lot. We'll talk to you again soon. look out for my next video where I fire this one up and we'll run through some temperatures as the engine warms up.